Okay, so I'm just going to go through some of these remediation problems. I'm not going to do the matching at all. I'm just going to do the more complicated problems. The matching is the matching. You should be able to do that. Graph the function by the equation. So these are the ones that I'm a little bit more concerned about. So graph the function given by the equation. So I have my original function. It's a quadratic. My original points on my quadratic are 0, 0. Okay, because 0 squared is 0. When I put in 1 in for x, because remember your quadratic is y equals x squared, so this is my parent function. So when I put 1 in for x, well, when 1 squared is 1. If I put 2 in for x, well, 2 squared is 4. That's where I get my x and y values from. I'm putting input and output. I put -1 in for x, -1 squared is +1. I put -2 in for this x here, and I get 4. So I have my nice little table right there, and so that's where my parent function is, just to give you an idea. And we'll find quicker ways to graph quadratics. So there's my original function. So I look at my equation here, and the first thing I look at is it goes 4 to the left. And so what I'm going to do is I'm going to actually subtract 4 from each of my x values. So I end up with -2 minus 4 is -6, -1 minus 4 is -5, 0 minus 4 is -4, 1 minus 4 is -3, 2 minus 4 is -2. And I'm just going to keep my y values the same for right now. So that was the first thing, because my equation is y, or my function is y equals 2, -2 times x plus 4 plus, squared plus 6. And so, again, that's just the equivalent. I just shifted all of my points from my original function 4 spaces to the right. So this would be 4 spaces, 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 and this would be 4 spaces. Okay. Next thing I see is I have a -2 right here. So what I'm going to do is I'm going to multiply all of my y values in my table by -2, because it's a stretch and a reflection. Okay, so I'm going to multiply. So anything that's on the outside of that parentheses, that's what you're going to multiply your negative or your y's by. So what's going to happen with my graph is it's going to flip and it's going to stretch out. Okay. So my x's stayed the same. I have the -6, -5, -4, -3, -2. 4 times -2 is -8. 1 times -2 is -2. 0 times -2 is 0. 1 times -2 is -2. And 4 times -2 is -8. So again, if I was actually graphing this, I would have, so my graph would be flipped upside down. So instead of going up like this, it would go down, and it would be kind of stretched out. Okay, so I'm just showing you step by step. So that would be my next step, that would stretch it out. But I also know that my graph is shifted 6 spaces up right here. So I add 6 to my y's. And so essentially all you're doing is you're 1, 2, 3, 4, 5, 6. I'm moving all of my points up. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And quadratics are symmetric. So essentially my x's stay the same, -6, -5, -4, -3, 2, -1. -8 plus 6 is -2, -2 plus 6 is 4, 0 plus 6 is 6, -2 plus 6 is 4, actually I have 1 there, I have an extra point, sorry about that, and then I have a -2. And if I graph these points, so -6, -2, sure enough that's going to be there, -5, 4 will be right here, -4, 6 will be up here, -3, 4 in here, and so this is what my graph looks like. Trying to make it a little bit neater. I need to make sure, you need to make sure that you have those points. So I know this is a pain, but that's what your graph would have to look like. So number 3, graph the function given by the equation. This one isn't as bad because I don't have as many points. So, so I have x, I have y, and I have my original equation, y is equal to radical x. There's my radical equation. Now my critical points here are 0, and then the square root of 0 is 0. It's going to be 1, so when I put 1 in for x, my y value is 1, and 4, which is basically when I put 4 in for x, what is my y value? It is 2. So those are the points I'm looking at. And so my original function is y is equal to radical, so it's 1/2 radical x minus 3 plus 1 on the outside. So first thing I do is I do my left and right. Right here I have right 3, so to my original graph I'm going to go right 3. Just before I do that, I'm going to graph really quickly my original function. So we have 0, 0, we have 1, 1, and 4, 2. So those are my original points. First thing, I move every point to the right 3 spaces. So that's the same thing here. So this is 3, 4, and 7, 0, 1, and 2. My y values didn't change. Again, I'm moving this point to the right. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so that's the first thing. Next thing I see is that I have a 1/2 on the outside, which means I'm multiplying all of my y values by a half. So it's a shrink of 1/2. So, sorry, I didn't mean to do that. So my table is going to look like, so I guess we'll go up here. My table is going to look like this. I still have the 3, the 4, and the 7. It's going to be 0, 1/2, and 1. And again, it's half the y distance. So 0, 0 stayed the same. Then this is going to be at a half, so a little bit lower. And this one's going to be at 1. So it's going to be shrink. It's going to get closer to the x-axis. My y values get half the size. And then the last thing with this is I have my +1 here, which means that all of my y values, my graph is shifted up 1, so I add 1 to all of my y values. So I have 3, 4, and 7, then it's 1, then that's going to be 3/2 or 1.5, and the next one is 2. And so all I'm going to do is shift my points up 1 space. So this is 1, this goes from 1/2 to 1.5, and instead of at 1, this is at 2. And so there's my new graph, which is right there. So I know that those are kind of a pain, but describe the transformation words of the graph of the function below. My original function looks like this. So little things that I notice from my original function, I know that there's going to be a reflection over the x-axis. I know that my function is moved to the right 1, 2 spaces because it moves from this little point here. It starts at 0, 0. It moves to the right 2, and I guess I'll use a different color for that. So to the right 2, 1, 2, and then up 1, 2, 3, 4, 5. So right 2 and up 5. So just describe it in words. So my graph moves right 2, reflection over the x-axis, and up 5. Okay, and that's it. So I always just use the same point, these kind of corresponding points. Where did it start? Where did it end? And it's flipped over. So for this one, this is going to be, you have, it's going to be right 7. And then a shrink or compression of 1/2. And the last thing is up 12. Okay. What's the equation of the parent function of the graph below? So you're just looking for the parent function. It's an exponential. So y equals, let's say, and we don't really know what the exponential is equal to 2. And then we look for a little caret symbol. Actually, it's here. 2 to the x power. Number 7 says find the equation of the function below. Okay, so this is the last one. What I realize is I know that my parent function is y equals 1 over x. And I know, I know that my original function is y equals 1 over x. I know that my graph usually, so kind of where they're asymptotes, this usually starts at 0, 0. My asymptote is usually at 0, but my graph has moved over. And so I just have to figure out, well, where did my graph move? Well, usually this point right here is at 0, 0, so how many spaces? 1, 2, 3, 4 right, and then 1 space up. And so 4 to the right would be, well, it's always the opposite, would be -4 in the denominator, and 1 up would be +1 on the outside. So, and that is that. That's the 1A remediation.